So today I'm going to be discussing Rust traits and CPP concepts with the aim of just trying to figure out if they're comparable, and if they are, is one of them better than the other? So let's kick off with traits. So for any of you who've gone through the Rust book or have come along to our Rust book club series, you'll probably get a sense of deja vu from these trait slides. All of the information comes from the book, which is a fantastic resource for learning about traits. And if you haven't seen our videos, I highly recommend it because Kira and Richard did a great job in covering the traits chapters. So what is a trait? Well, the Rust book gives us this definition. A trait defines functionality that a particular type has and can share with other types. We can use traits to define shared behavior in an abstract way. So we can almost think of them as analogous to interfaces from OO languages. When a struct in Rust implements a trait, we're saying that that type has the ability to do some behavior, but we're leaving the implementation detail down to the struct itself. I mean, that's usually the case. There are side cases where you can have traits with default implementations. So in that respect, you could also consider traits as a means of type restricted code reuse. But this is the typical definition for 99% of cases. And the book gives us this nice little example. So we've defined a trait here called summary, just using the trait keyword. It has a single method called summarize, which returns a string. We've also got this struct called news article, which has some other strings in it. And down here in our implementation block, we use this impl trait for syntax to specify that we extend news article using the summary trait. And so because of that, we then have to provide an implementation of the summarize method. So now you might be thinking, oh, cool. This must mean I can make functions that accept anything that implements summary. And yeah, you'd be right. The book gives us this next description of trait bounds. So we can use trait bounds to specify that a generic type can be any type that has certain behavior. The book gives us this little code sample as well. So we've got our argument here called item, and we use the impl keyword again to specify that this argument must implement the summary trait. And then, of course, because we're using a summary trait, the only methods that can be called on that item argument must be ones that live on the trait. If it sounds straightforward, that's because it is. But here's my next question. What if I wanted to restrict the argument so that it implemented 2 or 3 or n traits? Well, in C++ or some other OO language, you might start think, well, if my type has to implement 2 interfaces, then I'm going to have to create a type that implements both of those interfaces and then use that. And with that line of thinking, you'll start building an inheritance hierarchy. It's not always the most conducive way to think about things with Rust, but it is possible with super traits. So chapter 19 of the book covers super traits. And when writing a trait that depends on another, the depended on trait is called a super trait. And you would do this so that your trait definition can make use of associated items in that second trait. So here's a cut down example, again from the book. I think that's going to be the quote of the day. And here we define a trait called outline print. And we use this syntax here to specify that it depends on another format display. So display is a trait that comes from the format crate. And we've also got this simple struct of integers here. And we specify an implementation of outline print for point. But crucially, what we're not doing here is providing an implementation of format display for point either. So this code will actually fail to compile. So the compiler actually tells us point doesn't implement format display, tells us that, hey, we're implementing outline print, but point cannot be formatted with the default formatter, which, if I remember rightly, is a specific message you get when implementing format display. But more helpfully here, the trait format display is not implemented for point. And it then points out that, hey, outline print depends on format display. Lost where I am. But using super traits, as I said, isn't conducive Rust code all the time. And to be honest, it introduces type coupling, which in lots of cases is not desirable at all. So thankfully, Rust provides syntax for specifying that one single argument must implement multiple traits. And again, more Rustbook examples. We've got our item argument from the notify function from earlier, and that must import summary plus display. So it has to implement 2 traits. And you can imagine that would easily get really messy if you had multiple traits that argument had to implement, or if you had multiple arguments, your function definition would get really crazy long. So Rust also provides us this little bit of syntactic sugar to have a where clause style definition of which types implement which traits. And we can also specify that return types implement particular traits. So by adding the impl keyword before the return type, we can specify that this method must return something that implements summary. And just for the sake of completeness, earlier on in the book, tweet is implementing summary. But what we can't do is decide at runtime what that concrete type will be. So in this particular example, we're only returning one concrete type ever, and that's tweet. So this code is valid, but the code on this next slide will not compile. So we've got a function which just takes in a Boolean switch, and excuse me, depending on what the value of that Boolean is, we'll either return a news article, which you remember from the examples earlier, or a tweet. So Rust needs to be able to determine what the true concrete return type is at compile time. This is a process of the compiler called monomorphization. I really had to practice that. So monomorphization, and the code the compiler produces is static dispatch code. This means that the compiler has to figure out exactly which method is going to be called at compile time, which it can't do if it's got a runtime dependent variable. So to get around that problem, we use trait objects. So essentially with trait objects, we wrap the returned trait in a box, which ensures that the struct is created on the heap at runtime. So this allows the compiler to produce dynamic dispatch code instead. And that means that we can decide what our true return type is at runtime. And the syntax is not all that different, actually. So we just have this box which wraps a dynamic summary. So that's saying we're going to implement something that, sorry, we're going to create something that implements summary dynamically at runtime. And the returns are also fairly similar. It's the same types we were returning before, just wrapped with box new. One last note about trait bounds. We can use trait bounds to conditionally implement structs that use generic type parameters. So we've got another example from the book on screen. So here we've created a struct with a generic argument t, and it just owns 2 instances of that type t. We've also gone and implemented a constructor for pair of t, and just accepts 2 instances of t and stores them off. But we've also got this additional implementation block here. And using this syntax, we're specifying that we're implementing pair t for the case where t implements, the case where t implements the display or partial order trait. If t didn't implement those traits, this wouldn't compile. And when I say that, that doesn't mean your code will break. It doesn't mean that the compiler will error. It just means that that instance of that pair will not be able to use compare display, which is pretty powerful, I think. So that was admittedly quite a very quick whiz through of what traits can be used for in from the Rust book. So just to summarize what we covered, traits can define abstract behavior that can be utilized by multiple types. We can define function argument types with a trait. We can use traits to constrain function arguments. We can constrain return types using traits. We can conditionally create types on the heap at runtime using trait objects. And we can use traits to conditionally implement methods. And again, I'll big up the YouTube group as well. If you go back, you can see our old chapters where we've gone into traits in a lot more depth. So I think at this point, it might be a good idea just to check if there's any questions in the chat.
Nothing so far, but if anyone has any, feel free to drop them in.
Brill. Excellent. In that case, then I will move on to concepts. So as we go through here, you might start to see some strong differences or strong similarities.
Oh, sorry, Alex, I got a quick question.
Sure.
So in the previous slide, or the other previous two slides, you had a function that was here, display plus partial order. Is that, when you say it's and, so it has to, does it have to be of display and also partial order trait, or can it be either?
It has to be both.
It has to be both. Okay.
Yeah.
Thank you. Is there an or?
I don't believe there's an or. You could just implement two implementation blocks. So you could have impl display and a separate one for impl partial order. But maybe, yeah.
There isn't an or. There isn't one.
There isn't. No. I wonder if there'd be any use in having one, though. Would that actually be nice? Ah, great.
Color writers will hate you.
So then there is a use.
Alex, one more question. It's easy to find practices on other simpler things about Rust. Other places where I can practice traits, the toy problems on traits.
So the Rust book has a couple of good examples, but off the top of my head, there are quite a lot of crates and Rust libraries out there that implement traits. So I'd recommend. I'm trying to think of something specific that I could recommend, but they're used rather liberally.
There's a website called Exorcism, like exercise, but Exorcism, which has a bunch of tracks for different languages, and the Rust one for that I've looked at a bit, and it does have things where it separates by like type of functionality that you want to use, which might be what you want to look for, and then look for the ones that mention traits and have a play around with some of those exercises.
Thank you both.
There's Rustings as well. There's a section on traits. I'll link the actual section related to traits on the chat.
Cool. Thanks. Good question. Yeah, so C++ concepts. So concepts have been introduced in C++ 20, and a concept is basically, it's a constraint for template parameters which are evaluated at compile time. So for anyone who's unfamiliar, templates are C++'s mechanism for creating generic functions and generic classes. At compile time, the compiler will look at calls made to those functions and replace a template parameter. In this example here, we've called it t. It will replace t with the type provided in the actual call, and then it will try to compile that function using that type. So we've got a very simple example template function here. You could imagine that in our call to get max, if we provided two integers, then it would try to compile, we've got a simple ternary here, just comparing if A is bigger than B and returning A or B, depending on the output. Well, for an int, that's perfectly fine. We can do int size comparison and we can return an int. We've specified that T is also the return type, so that would be fine. But you could use that for float or anything that supports these operators. But crucially, that type T could theoretically be anything until we've passed in a type. But with concepts, we can now constrain type T as well. So in the second example, we've defined a concept called integral. We can see some familiarities with other C++ template constructs. So we still have the template class T syntax at the top, and we still .t around where we would want to replace our type. We use the new concept keyword to declare a concept named integral, and we point it at a function called, in this example, we're pointing at a function called stud is integral v. That just comes from the standard library. it actually comes from a header called type traits, which when I first thought about it, I go, wait, what language am I dealing with again? But it's just a simple function. It just returns true or false if the type provided is integral to the language. So whether it's an int, long, something built into C++. But we don't have to use predefined functions. We can write our own concepts as well. And we can do that using the requires keyword. So in this example, which I've kind of nicked from the Rust book again, I've made a concept called summarizable. And I've used this requires keyword here to build what's known as a requires expression. And I'm just saying that whatever my type T is, T must have a method called getName, and the return type of that must be convertible to a string. And so once we've defined a concept, we can utilize it again with the requires keyword. So we don't have to, we could define the requires condition using a requires expression. So we could put this expression right before our templated function, or we could define it somewhere else and pull it in from elsewhere. And we've got two syntactic sugary options as well. So we can either put it above in between the template structure and the function signature, or we can put it at the end, kind of like the where clause style in Rust. So if I put it all together, I've built this little code snippet. This one actually hasn't been stolen from the Rust book. So we've got a function, a templated function called summarize. It references a type T, and it requires the summarizable concept, which is the same one that we saw earlier with getName returning something convertible to string. And I've just made this little class which conforms to that concept. So it's got a getName method and it returns a string. And then I've just got a basic main function which creates it and summarizes it. If you're wondering, by the way, that book title, it was the first one that came up when I Googled funny book names, which I think is like fate for the Cardiff C++ group. And yeah, this will all compile fine. What's probably really interesting to look at is what would happen if I commented out getName. So if we comment out getName, book no longer conforms to the summarizable concept, and the compiler will complain at us. So it points me to line 30, which was our call to is summarizable. Great. And it points me to eventually points me back to the instance of is summarizable, but you know, this compiler output could be a little bit better. This is MSVC. GCC is a lot better. So here we actually see something that's, if I'm honest, starts to look a little bit like the Rust compiler. So we've got the offending call as it appears in code. We've then got the definition of the function itself. But here's the really interesting bit. So when we get right down to it, it says, hey, summarizable wasn't conformed to, and it was the getName that was invalid. So that's the first thing that's gone wrong, and that's the first thing it's tried to parse when it's gone through this. But we didn't have getName, so it's told you that that's what's missing, which is pretty nice. So when you think about it, the requires expression is actually really quite powerful. So I've got another example here on screen, and I don't know if anyone else has come up with this term. I've tried to coin it myself, so feel free to tear it apart or question it. But what I like to think of what we're doing here is specifying an anonymous interface for clocks. So any templated type that fulfills this clock concept must have a method called start, must have one called stop, and get time. But because it's a template argument, there's no restriction on the actual type being used, other than that they have these methods. Basically, we've gained the ability to perform some introspection on the type, but without relying on the actual type symbol. And going back to some of the points I made earlier with the Rust examples, this means that, like traits, with concepts, we've gained a way to ensure that a single type complies with multiple concepts, traits, whatever term you want to use. but without having to couple them together. So big plus for C++, C+++. But while this all looks really nice and is clearly going to be very useful, it's not actually new. That's one of the big things that surprised me about this. So introspection of templated types to control compilation was always possible. And to see how, we need to dig into SVNA and overload resolution rules. I'm not sure if SVNA is the correct pronunciation. It's the one I've adopted. So substitution failure is not an error, is a rule applied during overload resolution of function templates. When you call a templated method, the compiler has a list of potential methods that you could be trying to call. And when substituting the template type T or whatever with the type used in the calling code, if compilation of that method fails, the compiler doesn't immediately give up. It's going to keep trying the next method available until it runs out of potential candidates. And we could take advantage of this rule in a specific case. Specifically, we can take advantage of it if we specify that a templated type must contain a specific non-class type. So I've got a weird looking example here. We've got two templated functions called f. One of them has this additional syntax expecting that type T has some non-class type foo. We've also got a struct which just redefines int to foo. And we've got a main function which makes two calls to f, one using test as our T type and one using int. So when the compiler is looking at this, it'll go, okay, let's look at this first function. Got f test. Look at my first f function. We'll try and swap type T with test. So can we compile, can we actually access test : foo? Yes, it exists. So the compiler will say, okay, great, that matches, and we can use this definition one. When we look at the integer version, we'll look at the first f call again. Is there an int : foo? No. Move on to the next definition. We can just swap int for T in this case, so we'll use definition 2. But if we were to comment out this second definition, then we'd fail to compile because overload resolution would fail. We wouldn't have found a matching method. And this compiler output is sort of your classic terrible template message. But it does kind of tell us, this is the call that failed, and we basically failed template argument deduction. And it again points us to the only other candidate function that we could have called. In this toy example, that's somewhat helpful, but if you can imagine if we had lots of other candidates, then this error message would get much longer very quickly. So concepts in summary. Concepts define reusable constraints for templated types. And types can be made to comply with multiple concepts without them having to be coupled together. Using concepts simplifies the existing practice or abuse of the SVNA rule to constrain templated types. But concepts are not yet fully supported. C++ is still not fully implemented on all major compilers, and there's significant variation in compiler output. So it's worth noting that both traits and concepts they're really quite deep topics. Really, if you wanted to dive into them more, they deserve a talk each of their own. But I think as far as we're concerned, the level of detail covered today is enough to already start to make some meaningful comparisons between the two mechanisms. So at the start of this talk, I mentioned that we were going to find out if they are comparable. And then if they're comparable, we can start to make some good decisions. So are they comparable? Well, in some ways they are. So they're both mechanisms used to constrain types used by methods and classes or structs. They're both mechanisms that avoid the need for type coupling. They both provide mechanisms for type introspection. They both have a relatively nice syntax, which I'm going to sort of put a little post-it here. When I say that, I mean that the Rust trait syntax is nice Rust, and the concept syntax in C++ is nice C++. They're nice in their respective languages. And they both provide helpful compiler output, although MSVC is a bit iffy. But of course, they've got some extreme differences too. And I think the biggest one, if you take away nothing else from this talk, it's probably that this difference here. Traits are firmly a part of Rust's type system, and concepts are not a part of C++'s type system. So traits are additionally a mechanism to extend types and constrain arguments, but concepts only constrain arguments. And additionally, there's also a key difference in that traits are fully integrated into the Rust language. They're well established. They've been there for quite a while. I think they might have been in the first release. I'm sure somebody can correct me on that if I'm wrong. But concepts are, they're in the C+ standard. The compilers haven't fully caught up. They're pretty tacked on. So taking us back to Rocky, this is Rocky 3, by the way. Is there a winner? Can there be a winner? Really, I think the key component comes down to what they're trying to do. Traits are just doing so much more than concepts, because they're a means of constraining input arguments and they're an inheritance mechanism. They objectively serve a larger role in the language than concepts do in C++. But in the areas where they share purpose, I don't think the answer is that clear cut if one is better than the other. They're rather similar. If I had to pick a winner on syntax, I personally would pick Rust. But really, that's only because C++ is hamstrung with its long-standing template syntax. They also both do a good job in constraining arguments and providing type introspection and avoiding unnecessary coupling. Those are all fantastic goals that we would love to have in any language. And additionally, I think it's worth mentioning, as I was reading around this in preparation for this talk, I see this argument crop up online a lot that, a lot of modern C++ and new C++ ideas are just copying Rust. We're just copying Rust. And, I think at least in traits versus concepts, that's not entirely true. As we saw, while it's a bit hacky, we've always been able to do constraint checking in C++. It's just that now it looks a bit nicer and it's less hacky. So in short, much like Rocky Balboa and Apollo Creed, I don't think we'll ever be able to decide a true winner. That fight happens behind closed doors. But I guarantee there's some people in the chat or the comment section on YouTube that strongly disagree with me. So thank you for listening to me run through those two. I provided some links here to just some resources that I read and watched in preparation for this talk. I'll make sure that they're in the YouTube link as well. Yeah, thanks very much, everyone.
Thanks, Alex. The chat's been active, so I know we've definitely got some things to hear from people. I think there's a little bit of kind of discussion over concepts in the sense that how they actually restrict the type. Are they compiling that function for all of the types that satisfy those things? And the answer there was, no. It's when you try and use it, because of it tries to substitute in the possible template functions. If it fails to substitute it in, as you said, then it will start looking for another one and so on. And that kind of resolution is quite hard to follow sometimes.
Yes, I appreciate it can be difficult to follow. I was just trying to think. I think it's on my other computer. But while I was preparing these examples, I actually used Godbolt and I saved off a couple of the examples, so I could have shared them, but they're on my other PC. I'm very sorry.
No, you did a grand job. I just meant the template resolution itself in the compiler is quite hard to
Oh, I see what you said. Sorry.
First, the substitutions themselves. And we had someone mentioned that they have a bit of the history on concepts that they might want to share. You don't have to, no pressure, but if you want to unmute yourself and share some history on concepts, then go for it.
Hello. Yeah, I did a quick recce because I've been following C++ since the 90s. And then just before the year 2000, I realized that C++ template arguments do not have what I call domain restriction, i.e. they were an any rather than being able to be restricted by using concepts or what I originally looked at was SML, standard meta language, signatures as a way of dealing with that. But moving on, there's a very good book. I don't know if anyone's came across Elements of Programming. I think you mentioned it earlier. It's actually, there's a site, elementsofprogramming.com, and you can get a PDF for it on there. It's a very interesting book. It is able to model things like associativity, commutativity, to the extent that it looks at doing group theory elements. So that's very interesting thing to look at. It's not an easy read though. Then I looked quite some time ago at Concept GCC from Indiana University, which is done by Douglas Greger, Alexander Lumsdair, Jeremy Wilcock, and Jeremy Seek. That's back in 2006, 2007. That was basically concepts on GCC. That was the original concepts. Now what we have now is called Concepts Lite, which is, we don't get a lot of the facilities that were in that original type of implementation.
So were the concept, overloaded terms now. So were the ideas in those original books that you're talking about, were these ideas that were originally put to the C++ committee that were
there was an implementation. I mean, everyone was aware of Elements of Programming in those days. Concept GCC was an implementation on GCC of the earlier level of concepts on GCC 4.0.1. The source code for it isn't available anymore. All the links are dead for some reason, including the SVN. But there's also Andrew Sutton. He seems to be the main man behind the GCC implementation now. He's on GitHub as A Sutton / his implementations A Sutton GCC on GitHub. And he implements both the technical specification. There's two specifications. There's a technical specification and there's the working paper, which Clang implements the working paper. That's done by someone called Sar Raz. But Andrew Sutton's GCC implementation allows you to access both sets of implementations. I think that's about it.
Thank you very much. That's given us some good resources to go and have a look at. So it was A Sutton on GitHub.
Yes, yeah. ASUTTON. Yeah, on GitHub. Yeah.
Cool. I wrote it down correctly. Thank you very much.
Okay. Thank you.
Thank you.
I have a hypothetical question to ask.
Sure.
I'm a learner. I haven't spent much time learning C++, but I have layman's observation, which is C++ is adding new features similar to new languages like Rust. And just can you give me some reason that I can, for a new learner, just to avoid C++ at all, or the other way, give me some reasons why I have to learn about C++, despite I want to spend most of my time dealing with Rust. Thank you.
I feel like I have to defend the language now.
So stick with Rust.
I think you'll find a lot of people in this group probably agree with those sentiments. if I did have to come up with the most balanced view that I could, I think it truly depends on the kind of domains that you work in. So while Rust has got a huge amount of potential and it's got a huge amount of love, and there's quite a lot of developers that are actively looking to transition to Rust. In fact, I think it's been Stack Overflow's most loved language for like the last 5 years. It's still in 6 years. Sorry, it's still in its infancy. It still doesn't have like that almost sort of, I don't even want to say baked in. It's sort of permeated into lots of different industries. It's very common to see it in the engineering or scientific and computer games fields even now. That might change in the future. I don't really have enough future sight or even enough past sight to make predictions about how that's going to go, but there are grumblings of a new successor language for C++ called Carbon, which I don't know too much about. I do know that it's in the works. That doesn't mean it's actually going to turn into anything, because you know what Google are like with some of their products. I think there's a website somewhere which is just a Google product graveyard. It goes on for pages and pages. What I would say is that C++ has been around for a long time, and it's had numerous editions over the years. It's been very good at making best use of hardware. It's been very performant, and if you know what you're doing, it's a brilliant tool. But Rust just has all those extra safety features to make sure that you can do, you can make performant code, you can make it design cleanly. You don't have to worry as much about memory safety because that's handled for you by the compiler. I would honestly say my personal feeling is if you want to learn C++, it's great to learn about how memory works behind the scenes. And it's really good if you want to be employable for lots of legacy systems. I think the future trend is that people will probably be moving on towards things like Rust and maybe Carbon. But that's just an opinion of mine. I know that there are lots of people with different opinions. I'd almost suggest that you go and ask a wider group of people.
I can comment on the video game industry because that's the industry I'm part of. C++ is not going anywhere in the video game industry. So if you have any interest in the video game industry, C++ is hugely important. There's only one company that I know of in the entire world that uses Rust for video games, and that's Embark in Sweden. In fact, they're the ones that have developed the Ash crate, which is a wrapper around the Vulkan API. But there isn't too many people, too many jobs with Rust at the moment. So if you want to become an employable programmer, C++ will give you more opportunities. But also, I will add to what Alex is saying that if you spend a lot of time working with C++ code bases, you really understand better what Rust is doing for you, what problems it avoids. Things like point aliasing, dangling pointers, and those kind of things. You really appreciate why there's ownership, why there's lifetimes, and why it does what it does. Because you would have worked on too many terrible C++ code bases with just awful bugs and crash all the time.
I say something about C++ very briefly.
Yeah, of course.
Go ahead.
My main thing about C++ is the problem with pointers and references. Where do you use pointers? Where do you use references? And what happens to a complex code base with a lot of APIs, that some places you really need to use pointers, some places you really need to use references, but you tend to get a lot of this, like the ampersand in Rust, but you and star, you get ampersand star and stuff like that for dereferencing an iterator, returning a pointer, and then turn that into a reference. So it does get very messy. I won my code base that I'm trying to pull together again after a while, which is a compiler, source to source compiler. I'm seriously thinking of moving over to Rust and rewrite it from scratch in Rust. I don't know yet. It's still early days on looking at Rust because I've only started reading about it. I really need to go through your videos.
Do it.
I will do.
I'm porting my C++ ZX Spectrum emulator over to Rust right now, and I'm having a lot of fun doing it.
Is it open source? Have you got a link?
No, it's not open source just yet. I was actually thinking of doing some YouTube videos of me writing it, streaming it as well. So I kind of write it first, so I know what I'm doing, and then rewrite it again the second time for videos. But I don't know. I after hearing my voice on the uploads of my previous videos with you guys, I feel less confident. I can't stand hearing my voice. I bet you can't either.
Yeah, never listen back. Don't do it. It's just nobody likes the sound of their own voice. We're programmed that way.
Yeah, I have a unique point to make. I read on Quora, someone is saying that LLVM has 50 million lines of code. It is one of the human's largest software endeavor. So my point is that computer projects benefiting from LLVM is like riding on a wave for success. So I guess that Rust benefits a lot from the advancement of LLVM. Am I right?
Yes.
Absolutely.
So does C++.
So does C++. And LLVM's written in C++, and it's not going to change anytime soon. You know, people aren't going to rewrite LLVM in Rust overnight. I'm not sure if there are any plans to, but I think the advice that you kind of see even with Carbon and stuff is that if you're starting a project from scratch, Rust is a lot easier to get up and running quicker, especially for hobby programming. With Cargo, you know, your build system is much easier, the test system's much easier. And even having access to projects outside, like if you don't mind about safety in other people's code, you can bind against other people's C interfaces fairly easily. But if you've got an existing code base, which is the situation that most companies will have and what LLVM has, then you're not going to rewrite it in Rust, because there's the amount of time sunk would be way too much, and also that even the architecture of where you're implementing it might not even be possible in Rust without just writing a bunch of unsafe code, which isn't going to give you the benefits of Rust then if you're doing it absolutely everywhere. So that's why Carbon exists. Is if you read the little disclaimer where they've released Carbon, they've said, don't, if you need to start a fresh project, that's not what Carbon's for. It's for swapping out like file by file pretty much your C++ code into a slightly safer alternative.
I actually disagree with that.
Oh, which bit? All of it?
I actually think Carbon's a waste of time. I can't see it going anywhere, and mainly because it has to rely on the broken type system that C++ has. And
I haven't used Carbon. I wouldn't say use it, but it's just that's what it's designed for, even if it's not doing it successfully.
I've watched all the talks, I've watched some videos on it and stuff like that. I've messed around on the Godbolt stuff, and I can't see it going anywhere outside Google. I think it's a language for a very specific niche that Google has, but I can't see anyone else using it. I don't see the benefit of the time and investment in a language that is fundamentally as broken as C++ from the very beginning. They talk about safety, but you have to use the C++ type safe system, which is really broken. Aaron talked about references and pointers, and they're not interchangeable. They are both pointers, but for example, you can't use a reference in an optional. You have to use a pointer. So now the optional is the pointer, which is nullable. We usually use references for makes something non-nullable. But it's just fundamentally broken, and Carbon has to do that to do the two-way thing. I can't see it going anywhere. I don't see it offering us the benefits of other languages that are out like Zig or Rust.
I'm very happy to hear that, because that's exactly my feeling for a long time, and everybody else seems to be really, really excited about it, and I don't get why.
Yeah, I can't see it. I think it's
It's
going
new
nowhere.
and it's shiny.
Yeah.
Well, it's a presentation. There is nothing that can be shiny, because there is nothing yet.
Yeah, they don't have a compiler. They can't even use floats.
But it's from Google.
Yeah.
At that moment, it's just a series of really interesting text documents. It's just
some horrible syntax as well. For example, when they do they use these square braces after the function name to say how you use the self for this kind of parameter, and it's really, really horrible. Rust does that a lot better by having the sort of self as a first parameter in an impl block with or reference self or reference mute self. The Carbon uses horrible brace syntax. It just makes the code even harder to read. I hope they change that.
I feel like they're trying to solve an impossible problem. Like you can't retrofit something like that onto C++.
Well, here's the problem with C++, right? Every compiler vendor uses its own form of name mangling to handle overrides. So unless the Carbon uses the same compiler as your C++ uses, you're not going to get that sort of ABI compatibility. If you, for example, have a lib file which is compiled by, say, GCC, and you try to use it with CLang, use Carbon with a sort of CLang and backed compiler, because I think it just generates C++ code. You're not going to get compatibility, I don't think.
Just a quick aside, I'm working on a system that's basically a language, a meta language, that's a semantic superset of C++, Java, and C# and possibly Rust. Maybe, I don't know. I don't understand Rust well enough yet. But the whole idea is to have a semantic superset and to have a parser into an AST, and then to be able to raise or lower that AST into my language. So that you, for example, things like Koenig lookup, you might have that on a module, and everything will then be Koenig lookup in that module when the C++ has been taken across, same with Java and so forth. And then an ABI specifier, which is a set of mappings, so that you can map onto name mangling, onto exception handling mechanisms, etc. It's all very pie in the sky at the moment, but it's something I'm working on. Anyway, can we get back to Rust? Sorry about that.
So thanks, Kira. You beat me to it. So Kira's just added the Discord and YouTube to the chat. I think there's a little bit of housekeeping to sort out just before we tidy up, because we'll be finishing it pretty shortly. I'm just trying to remember, is it the 14th of September is our next scheduled talk? Is that right, Kira?
Yep. Unless we could maybe squeeze in a Matt live coding one. I haven't actually properly asked you yet, Matt, so I'll ask you about it later.
That may be difficult on that particular day, because I'm moving to Wales on the 12th of September.
Oh yeah, no, it wouldn't have been.
I might not even have internet.
Exciting.
Or my new computer set up.
We'll talk. But on the 14th, I think it'll be Chris anyway. Chris is going to do a presentation on building a plugin and using for Juice, which will be interesting. I don't know anything about Juice whatsoever, but we had a request a while back for a talk on Juice, so Chris is.
Is that C++ library?
Yes.
It does the graphics and stuff.
It's audio.
Like Boost kind of thing.
But that's the only thing that's actually scheduled in the pipeline. We might get something in sooner, but anyone can do a talk. If you get us in the Discord and just say, hey, I'd like to do a talk on X topic, as long as it's Rust or C++ or both, we can sort it out for you. And there's no barriers to entry. Any skill sets are allowed. So the way I actually approach this is that I didn't know, I'd been through the Rust book with these guys and learned about traits. I had heard of concepts. I hadn't really appreciated what they were. So I agreed to do the talk and then used it as an excuse to go and learn about the topic. So don't be put off by saying, oh, I'm no expert, or I'm still new to this. It really is a place just to share what we've learned. And if you don't know something, but you talk about it, you might get some information back. So yeah, open to all.
I will add that I don't think many companies, technically not in the video game industry, are using C++20. I think the maximum one we've been using C++17, and so concepts, I've never seen them in the wild. They're a very nefarious thing for me at the moment.
I'm hoping to move my compiler over to use in concepts. So that's one reason I sort of gemmed up for this talk as well. Shame is it's a bit not a bit longer. Would it be possible to move the format to an hour and a half? Because hours just tend to go by. You get all your introductory stuff, everything gets talked about, and then there's not all the ramifications for people to talk about afterwards. Just a suggestion. Yeah,
so we did used to do much longer presentations, and what we found that the shorter format was slightly more popular. But having said that, there's no hard and fast rule. It's just something we're still fairly new to this in general. It's all down to experimentation. We certainly could.
We sometimes move the chat afterwards as well onto Discord. So then on Discord, you can go into like this, I forgot what it's called, this like breakout.
The voice chat.
The voice chat, that's it. And carry on talking about it there. I guess I think an hour and a half with no discussion at the end is kind of too much, but I agree, if you've got like an hour talk and then half-hour talking, that could be like chatting afterwards, that could be a really nice format.
Right.
I had one question actually. I just thought, with the concept syntax, you might have shown this already, but if you want to implement the concept on two different types, like two generic parameters, what does that look like? I think
so I don't actually think I have a slide that shows that.
A comma, you separate them by a comma in the angle braces.
Yes. So just as if you had a templated function that takes in two. Sorry, I'm throwing myself off now. If you had two templated types, so let's pretend it's T and U, in your requires, you would also plug in T and U with the comma separator, as Aaron said.
So if you wanted them to have so T needs to be summarizable and U needs to be printable or something, is there a way to have your two different types have two different requirements?
I'm sure somebody's going to correct me now. I think they're chainable, but now I'm not entirely sure. Don't quote me on that. Perhaps somebody else knows.
You have more than one concept. So when you're using the concept keyword, ignoring the requires part, just at the concept, and you want a type to have multiple concepts. How is that done?
So again, I still need to make sure I'm correct about this, but I'm pretty certain if you can use requires and chain the you can chain the concepts together.
You get a lot of connectives as well. You get and, or, etc.
Boolean. Okay.
Yeah.
I'm a little ashamed of myself now. I just thought, oh, that's a huge gaping hole in the presentation.
There's concepts are. You read the documentation for concepts. I mean, I've printed out 2, 3, papers on them, technical specification. I'll put details for these. A document by Stroustrup, which is an attempt to simplify everything and bring everything down to earth. And then there's a document on the actual implementation details. I think that might be an earlier version. That might be of the earlier versions before Concepts Light.
Have you got links to those?
I will put them on the Discord.
Brill. Thank you very much.
Yeah. Okay.
If there's nothing else, I'm afraid I actually need to shoot off promptly today. So yeah, thank you very much, everyone, for coming along. Hope I've imparted some knowledge. Hope you've learned something useful. And yeah, feel free to just give us a shout in the Discord if you'd like to present a topic on anything to do with Rust or C++ in the future.
Thanks for the presentation.
Thanks,
It was
Alex.
great.
Yeah, thanks, Alex.
Thank you very much.
Thank you. Cheers.
Bye-bye.